description applies to different types or activities carried out at sea like offshore oil exploitation or production of wind energy. Now we talk about the function of offshore structure. The function of offshore structure is: first, exploratory drilling structure. A mobile offshore drilling unit or MODU configuration is largely determined by the variable deck, payload, and transit speed requirements. The second, production structure. A production unit can have several functions, example, processing, drilling, workover, accommodation, oil storage, and reservoir support. The third, storage structure stores the crude oil temporarily at the offshore site before its transportation to the shore for processing. Because the location of the offshore building located in the sea, so often happens corrosion. Corrosion happens is heating corrosion and reverse corrosion.
Corrosion. Corrosion is described as formation of compounds on the surface of a metal when it is exposed to air and/or water or an electrolyte like salt water. Typically, once a metal corrodes, it forms compounds known as oxides or hydrated oxides.
Okay guys, I will explain about the pitting corrosion. Generally, there are four requirements of corrosion. There are cathode, anode, electrolyte, and the complex of the things. Pitting corrosion means that corrosion of a metal surface confined to the point or small area that takes the form of the cavities. Pitting factor means that the ratio of the depth of the deepest pit resulting from a corrosion divided by the average penetration as calculated from weight loss. Pitting corrosion is localized from corrosive attacks that produce holes or small pits in the metal. The bulk of the surface remains unaffected. Pitting is often found in a situation where resistance against general corrosion is conferred by passive surface films. Localized pitting attack is found where the passive films have broken down.
We'd see that a steel object is made up of a lattice of iron atoms, with tiny lumps of carbon dotted through the lattice. Some of these will be exposed at the surface. If a lump is in contact with water, it will have contact not just with water molecules, but also dissolved salts and dissolved oxygen from the air. What we have here is a kind of natural galvanic cell. The carbon acts as an electrode because it provides a ready location for electron transfer. Here's what happens. When an oxygen molecule slams into the carbon, it grabs two electrons, which are dragged through the iron lattice from an iron atom. The oxygen readily reacts with water to form hydroxide ions. At the same time, the iron atom gives up two electrons to become an iron 2 ion, which is repelled out of the lattice and dissolves into the aqueous solution. Without access to this solution, there's no way for iron 2 ions to be formed. This explains why rusting happens much more slowly in dry conditions.
Pitting can be most dangerous forms of corrosion because it is difficult to anticipate and prevent, relatively difficult to detect, occurs very rapidly, and penetrates a metal without causing it to lose a significant amount of weight. The corrosion main factor. Aero manufacture process create a hole of wood. There are several factors of the pitting corrosion. The first is about the error of manufacture process, create a hole or a bulge, and then there are a scratch or cracks by the effect of treatment or erosion from the surroundings. And the third is about there are the heterogeneous composition deep inside and create a slip and dislocation. And the last is the shape was collecting water. And we talk about the prevention. The prevention is we can do some thing that can prevent that pitting corrosion happen. The first is good coating, and second is the normalizing with the environment, good design, neat manufacture process, and anodic protection, of course. And there are some examples of the pitting corrosion. These examples of pitted surface was produced by exposing a specimen of aluminium A92519 to 3.5% NaCl and during 7 days. The width of the picture is approximately 1 millimeter. A local cell that leads to the initiation of a pit can be caused by an abnormal anodic site surrounded by normal surface which acts as a cathode, or by the presence of an abnormal cathodic site disappeared due to the corrosion.
Crevasse corrosion is a localized form of corrosion that occurs in the presence of stagnant solution in a small or micro crevasse. Local chemistry changes in crevasse or shielded areas such as those formed under gasket, washer, insulating material, fasten heads, surface deposits, disc bond, coating, thread, and lap joint and clamp can result in crevasse corrosion.
Initially, anodic and cathodic processes occur all over the surface of metal. The crevasse now becomes a focal anode and the net change in the crevasse becomes positive. This set up a potential different and negative ion from solution flow into the crevasse. The chloride ions encourage corrosion and also form complex with the metal ions that react with water to produce acid. The acid combines with fluoride to attack the metal.
There are some factors influence crevasse corrosion such as material, include alloy composition or metal graphic structure, and then environmental conditions such as oxygen concentration, acid concentration, and temperature, then geometrical features of crevasse like surface roughness,